Determine the inverse of matrix A. The first step in determining the inverse is we want to calculate the determinant, which is this kind of setup here. We want to get the determinant of matrix A. And how do we do that? Well, the determinant of matrix A, something like this, is going to be, see we have a 1 here in the top left, right? So it's going to be 1 multiplied by, we open a bracket here, and in here we're going to have, we work down from the 1 and we see this kind of set up here between the 3 and the minus 2, right? So we're going to have a minus 3 multiplied by the minus 2 minus the product of these two. So we'll have a minus 2 and a 4 in here. Okay. And next up then, that was a plus 1. We're going to have minus this second item, it happens to be a 1 as well, minus 1 outside of brackets. And we're going to have the product of two things here minus the product or multiplication of two other items. Now you see where this 1 is situated, so the minus 3 or 2 can't come into play, that middle column can't be coming into play, and the top row doesn't come into play. So this time the 2 is going to be multiplied by the minus 2, so we'll have a 2 times the minus 2 here, and the crossways one the other way then is going to be the 3 times the 4. 3 times the 4. And the next bit then is going to be plus the last item in the top row there, plus the 1 times, we'll set this up again, minus the product of two other guys here. Now that 1 means that the last row, the last column or the first row can't come into play here. So we have 2 minus 2, 2 minus 2, and 3 times minus 3. Doesn't matter if the minus 3 goes there or there. The order of multiplication isn't important. So that tidies up a little bit then to 1 times minus 3 times minus 2 is going to be plus 6 minus, now minus 2 times 4 is going to be minus 8, and the minus 8 actually gives us the plus 8. Tricky. Then we have minus 1 times 2 times minus 2 is minus 4 minus 3 times 4 is 12. And then finally we have plus 1 times 2 times minus 2 is minus 4 minus 3 times minus 3 is minus 9, and minus 9 is actually going to give us a plus 9. So tidying that up another step, we'll have 1 multiplied by 6 plus 8 is 14, minus 1 multiplied by minus 16, plus 1 multiplied by minus 4 plus 9 is the same as 9 minus 4, that gives us 5. So then we have 14 minus 1 times minus 16 gives us plus 16 plus 5. We add those 3 items together and we get 35. So what did we just get there? We got the determinant. So I'm going to write that up top here. The determinant of the matrix is equal to 35. And I'm going to do some space clearing. Right. Next up. Next we need to create the matrix of cofactors. We need the matrix of cofactors, which is C. It's donated usually with a C. And this is done like so, right? We're going to have a plus. And I'm going to set up the brackets here. And then you'll have a minus. something going on here, a plus, something going on here. This will give us, come to one number, this will come to one number here. And for the second row then, that was a minus, so the next one, that was a plus, so the next one's going to be a minus. We're going to have a plus and a minus. So for the last row we'll have a plus, minus times whatever happens in there, and a plus whatever happens in here. So the top one, we're looking here at 1 again, so like the determinant, something similar to the determinant. Minus 3 times minus 2 is plus 6. Minus, now it's going to be, it has to be between the minus 2 and the 4. So minus 2 times 4 is minus 8. So that's going to end up being plus 8. Then we move on to the second item here, the 1. So that rules out the middle column and the top row. So if 2 and minus 2 is going to be minus 4 minus 3 times 4 is 12, right? So that's going to be minus 4 minus 12. And then we'll have the last row at the top. 2 times minus 2 is minus 4. Minus 3 times 3 is minus 9. So minus 9 will result in a plus 9. Right, so that should be similar, something similar to your calculations for the determinant. Okay, I think it is. So those will pan out to be 14 there. Minus 16 minus 16 will give us a plus 16. 9 minus 4 will be 5. Downstairs here then, the middle row, first element on the second row is the 2. So that blocks out that, I like to think of it, blocks out these numbers and blocks out the first column. So now we're going to have 1 minus 2, which is minus 2, minus. Remember that middle row is blocked out and the first column is blocked out. So then we're going to have minus 2 times the 1, which is minus 2. And minus 2 with a minus in front of it, that becomes a plus 2. Now for the minus 3, the middle column and the middle row are blocked out. So 1 minus 2 is minus 2. I'll walk about there. 1 second now. Hit the wrong button on the biro. Right, so minus 2 minus 3. Next one over here, we're at the 4. So we're going to have 1 times minus 2 is minus 2. Minus 1 times 3 is 3. Downstairs, we're looking at the 3. So it's going to be 1 times 4 is 4. Minus 3 times 1 is minus 3, so it's going to be plus 3. Over here then we have the minus 2 here, bottom row, middle column. So we have 1 times 4, which is 4, minus 2. Bottom right hand corner, we end up with 1 minus 3, minus 3, minus 2. So we can tidy up these ones. That's just going to be 0. Let's check my answers here. Right, -2 minus 3 is going to be -5. And then we have, this guy's going to come to +5 because that's inside the bracket comes to -5, and a minus by that gives us a +5. Okay, bottom row, that comes to 7. This guy comes to 4 minus 2 is 2. Minus in front of that becomes -2. Minus 3 times, or take away 2 is -5. Right, so our matrix of cofactors C equals 14, 16, and 5 across the top row. Then we have 0, -5, and 5. And on the bottom row we have 7, -2, and -5. So that's our matrix of cofactors. Alright, so I'm going to wipe out our work here. Now the next step is to get the transpose of this matrix. Right, I'm going to go back up top here just for space. C transpose. This means that the first row becomes the first column. 14, 16, 5. The second row becomes the second column. 0, -5, 5. And lastly, the last row becomes the last column. 7, -2, -5. So that's the transpose. And to get the inverse of matrix A, the inverse is done by multiplying the transpose, or dividing the transpose if you like, or multiplying the transpose by 1 over the determinant. Right, the wee dot there means multiplication. So to multiply this by 1 over the determinant, we just get 1 over 35 multiplied by this guy here. So I'm going to try and copy this here now. I need to kind of lasso it somehow or another. Right, I'll just write it out, it's quicker. 14, 0, 7, 16, -5, -2, 5, 5, -5. So you could multiply each element, which you're effectively just writing each element over 35. You could also do that. That'd be also a good answer. So this here is the inverse of matrix A. So it's a kind of stepwise procedure. You have to practice it to get used to it. You can then be able to bang it out in the exam. Simple as that. And there's tricky little calculations.